Hi and welcome to the next part of electricity, answering open-ended questions on electricity. So let's continue from where we left off. In this question, the same electrical parts in the toy car are connected to form circuit B as shown. Okay, again, before we continue, please remember, if these videos have been helpful, please consider subscribing so that when I upload the videos, you will be notified. And please, you can spread the word around for those of you who think you know anyone who can benefit from this video. You can inform them about my channel. Alright, so back to the questions. The same electrical parts in the toy car are connected. So this is a continuation from the previous question here, the toy car question. Okay, now we form circuit B, different circuit. State an advantage of circuit B compared to circuit A. So we need to know the differences. Usually, if you have more than one setup, there will always be differences. Usually there will be one difference. But in this case, maybe there might be more than one differences. So let's take a look. Alright, of course it's helpful if you can get it side by side. But let's see. Here is quite straightforward. All the components are in series. And here the lights are in series with each other. But it's parallel to the speaker. And the motor is parallel to both of them. Now, for this kind of question, when you have components arranged in what do we call it, parallel, we always talk about this one particular advantage. All right. So this is like another key phrase. So this is how we're going to write the answer down. We will say, we will state first. It's good to state what type of circuit it is. Here usually we say components, but again, remember I mentioned one of the important thing is to use words from the question, and to be consistent, I'm just going to use the words from the question. I will say the electrical parts. Okay, instead of saying the components, I'm just saying the electrical parts. Again, why? The reason because I want to be consistent, because I mentioned one of the important things is to use words from the question. So we can say the electrical parts are arranged in a parallel arrangements to each other. Okay, then we can say the advantage now. So if the light did not work, we just say, if we want to shorten it, okay, so we say if one of the electrical parts did not function, the other two can still function. Okay, this is shortening it. But if let's say we stick to what I said, using words from the question, then we need to use the word light, speaker, motor. Okay, we need to use that. So how we write it down? We can say, so if the lights did not function, okay, the speaker and motor can still function. Okay, the reason why I opt to shorten the answer, because you see, if I use the words from the question, I need to also explain if, okay, I already explained if the lights did not function. Now I have to say, and if the speaker did not function, the lights and motor can still function. And if the motor did not function, the light and the speaker can still function. Alright, so that's why I opted to shorten the answer. Now, this is just a state question. If this is an explain question, I would need to expand on this answer. Okay, if this is an explain question, I will need to say this second part here, which is a key phrase, and I've mentioned it before. Alright, whenever you talk about series arrangement or parallel arrangement, you need to talk about the path of electricity. So here we can say, as there is more than one path for electricity to flow, so it still forms a closed circuit and electricity can still flow to the other components. Now, this is again not for this question. This is if it is an explain question. So this is how we answer. Alright. Again, the key phrase. Let's highlight the key phrases. This is the key phrases. Path for electricity to flow. This is for questions that is asking about parallel or series arrangement. And then this is the standard key phrase. Forms a closed circuit, electricity can still flow. Alright, next question. Tom conducted an experiment using a circuit as shown. He placed different materials in the circuit and recorded his results in the table. State the aims of Tom's experiment. Okay, so state the aim. Aim question, we always start with to find out. Some students like to write to see, but to see is not very good, because to see means you are using your eyes only. To find out, okay, if to find out, you can use other senses, your eyes, your hearing, okay, your sight, your hearing, your touch, all the other senses. So here we say to find out if the change variable. So there is a template. I usually teach my students certain questions have certain templates. For this question, for example, the template. So let me write down the template here. The template is to find out if the change variable affects the results. Alright, so again, this kind of question is not really topical based. It's more of how you learn to answer the question. So to find out if the different materials, okay, here if you write will cause the bulb to light up. Again, this is being consistent using words from the question. Okay, but this is not the best way to write for this question. Okay, the better way is to find out if the different materials can conduct electricity. Okay, so this is the better way to write. But if you write the first way, by right, they should accept your answer. But again, like I've said before, certain schools will have certain specific way they require you to answer. So again, check with your teachers. Next question. Tom set up another circuit as shown where materials A, B and C could be placed. Now, this is again continuation from the previous one. So let's just talk about the different materials first. So A and B are conductors and C is insulator. So we remember C is an insulator here. Alright. And we place them in different positions. There's 3 positions here. Now from the circuit itself, if let's say your concept is good in this topic, you know if you put an insulator here, the whole bulb will not light up. all the 3 bulbs will not light up, because if I use the key phrase, I would say there's one path for electricity to flow, or I can say the electricity has to flow through position 3 in order for there to be a closed circuit. Okay, I can say it like that. Now, which position should materials A, B, and C be placed so that none of the bulbs light up? Okay, this is the first one. And number 2, most light up. Okay, so of course we want none to light up. You put C here, and it doesn't matter where you put A and B. But if I want most to light up, of course I cannot put C over there. So it's, straight away I can know I can put A here or B, doesn't matter. Now you just need to trace. Again, like I mentioned before, it's like kindergarten work. If I put C at position 1, when it comes here, it will not form a closed circuit and electricity will not flow through there. So where will electricity flow? Electricity will flow through here. And there's only one bulb lighting up. Okay, but if I put I put material C instead here, so let's write down material C here. Okay, if I put C here, then the electricity will not be able to flow through here. It will stop there, and it will continue to flow here, which will result in 2 bulbs lighting up. So that's where we're going to put C at position 2. So this is where we put B. Alright, so quite straightforward question. Next question. Jerry set up a circuit as shown. He measured the brightness of the bulbs and plotted the following graph. So brightness of the bulbs, number of batteries. Before we answer this question, let's talk a bit on graph. Now, for this axis here, okay, this one here, going horizontally. Now, to make things easier, just remember that on this axis, it is always going to be increasing. It's never going to be decreasing. Okay, so it's always increasing. As for this other axis, the vertical axis, it depends on the shape of the graph. If the graph is going up, then it is increasing. But if the graph is going down, then it's decreasing. So always remember this. So we can always say this part here is increasing. We can say as the number of batteries increases, because it's always going to be increasing, then we look at this. If it goes down, we say the number of brightness of bulb decreases. If it goes up, we say brightness of bulb increases. Alright. So again, to make things simpler, the horizontal axis that's going this way is always going to be increasing. For the vertical axis, it depends on the graph. Okay, this is for 90% of the time. Of course, you will have some graph that is that's just going up like that. If it's just going up like that, okay, we're talking about a line graph, then this is the only time where the horizontal axis is not increasing. It's remaining at one position. Alright, okay, so let's carry on with this question here. State the relationship. Okay, I've already mentioned the technique to answer this question. The horizontal axis here, the number of batteries is always increasing. I prefer to use as something, okay, start the answer with S, because if we start the answer with S, it's always going to be increase or decrease, and it's going to be the same for the next part. So here I say as the number of batteries increases, the brightness of the bulbs increases. Okay, so you can see I use increase for both here. Okay, so if you use S, usually you will say increase or decrease. That's all. If you don't use S, if you say, for example, some students will say when there are more batteries, then they will say, oh, then the brightness will be brighter, something like that. I don't really advise to do that, because then you need to come out with your own words, like batteries increase as the speed of car is faster, the braking distance is further. So it's a bit tricky because you need to come out with your own words. But if you use as, so you can say as the speed of car increases, the braking distance increases. You see, you're always going to use increase or decrease. All right. That's the first thing to take note of. The second thing that you need to take note of is when you write this kind of answer, you always want to mention the change variable first. Okay, the change variable first, and then you mention the result. Sometimes in the question itself, they will, I don't know whether they do it purposely or what, they will say state the relationship between the brightness of bulbs and the number of batteries. Then the students might end up saying as the brightness increases, the number of batteries increases. Okay, by right, that doesn't make sense, because what you're saying is when brightness increase, then it affects the batteries. But we know that when the brightness increase or decrease, okay, it cannot really affect anything. But in fact, it's the other way around. When the batteries increase or decreases, that will affect the brightness of the bulb. So this is the second thing that you need to take note of. Alright, carry on with the next question. Jerry added fifth battery in the circuit to the circuit and recorded his observation on the graph. And you see here, suddenly there's nothing here. Brightness became 0. Give a reason why the brightness of the bulbs changed when the fifth battery was added. It's quite a common question. I'm going to answer this in almost an explained way. Instead of just giving a reason, I will say there was too much, you can say electricity, you can say electrical current, you can even say current, okay, flowing through the bulb, so the filament melted. Okay, the filament melted, and then the standard key phrase, causing an open circuit and electricity cannot flow through. So the brightness, okay, I was looking for the word to use from the question, of the bulbs became 0 units. Okay, this is in explain question. But if they ask, give a reason why. Now, give a reason why. I've noticed that if the question is give a reason and you have why, they actually expect you to answer in an explain question. Okay? So it's safer to answer it in how I've written it down here. And there are certain cases where they say just give a reason, not why. For example, they say when the fifth battery was added, the brightness of the bulb or the bulbs did not light up. And they just say give a reason. Okay? So usually when they phrase it like that, I'm saying usually, again, go back to your school and ask. When they say give a reason, then just give a reason. You can just say the filament has melted, so there's an open circuit. You can say like that. But if they say give a reason why, it's better to approach it in how I've written down here, like an explain question. Okay, almost towards the end of the questions here. Next question, Susan set up 2 circuits M and N as shown. Both bulbs in the circuits lit up when the switches were closed. Okay, so here we always look for the difference in both circuit. Here not only are the bulbs arranged differently, there's also a coin here. So let's see what they want from us. So this is just a true, false, or not possible to tell. When bulb X fuses, this is bulb X, the other bulb in the circuit will not light up. This is definitely false because there's more than one path for electricity. Notice I'm using the key phrase so that you get used to it. Okay, more than one path for electricity to flow, so it still forms a closed circuit. And remember, I'm going to be specific. Electricity can still flow through the other bulb. If they name this bulb Z or whatever, then you say it can still flow through bulb Z. Next, adding one more battery to circuit N will cause bulb X to be brighter. This by right, yes. Okay, cause bulb X to be brighter. But if we look at the previous question, there's a chance that it could fuse. Okay, it could fuse, the bulb it could fuse. Oh yeah, so we can use that word also, fuse, in the previous question. Let's say they just say give a reason. You can say the bulb fuses. Okay, or the bulb fused. Alright. So for this case, they are not very clear, but why I chose this, because this is the general concept. When more bulbs are added, okay, the bulbs will be brighter. But I'm not surprised at all if this is the actual answer, because it's not possible to tell. It's not possible to tell in a way because it could become brighter or it could fuse. Right? So maybe for this case, I'll go with this. It's a better argument also. Right? It's a better argument because it could fuse. No one knows. Alright. Next question. When bulb Y is removed from the bulb holder, the other bulb will not light up. This is true. The coin is made of copper. Not possible to tell. Okay, so there's two not possible to tell. Alright. And to be honest, this question here can go both ways. Alright, like I say, the main concept that we teach is that when you add batteries, the bulbs will become brighter. But why I think this is also a good argument, because it could fuse. We do not know. Alright. Next question. Ahmad conducted an experiment using circuit Y as shown below, or as shown. He added a bulb in parallel to bulb X. So this is bulb X here, the same bulb, and then he put in one bulb at a time. All the electrical parts are working. Complete the bar graph. So since they are added in parallel, remember the concept. When you add bulbs in parallel, the brightness remains the same. So bulb 2 and bulb 3 will have the same brightness. And last question, reduce the brightness without adding or removing anything. So we just need to arrange the bulbs or rearrange the bulbs into a series arrangement. So we keep bulb X there, its original location here. Okay, bulb X. Alright, so what? Notice that I label exactly like what they label here, and then I put in two more bulbs. Anywhere, it doesn't matter as long as they are in series. There you go. Alright, so that's the last question. So remember the key phrases, remember the answering techniques. Now, once again, if this video has been helpful, please do share around so that more people can benefit from this, and please remember to subscribe. Thank you very much, and see you again in the next video.